Hello everybody, welcome to another stream. How's it going? So, last stream it kind of ended, like the one that went up on the recording at least. I'll recap from there. So we were trying to get the bloom shader up and running, and I got it working in the end to some degree, where it downsamples the scene image basically with a bit of a different kind of filtering. And the problem that we encountered is when we went into render dock and pressed a capture and then when I tried to capture, it was for some reason just taking all the resources on my machine and then it crashed the machine. So it was either the problem that I'm about to show. So basically the issue that I needed to solve was when we create a temporary resource view, what I was doing is instead I was creating it as an actual whole new texture, which means it was allocating more memory, and there were completely different textures that were being allocated for each texture view of the MIP chain for the bloom texture. So that was one bug there, and then the next bug was after that in the shader code, so in that bloom down sample. I corrected the problem where I was, I've used the Morton code, so I've taken this 1D. This used to be an 8.8. So in the thread group used to be a size of 8x8, meaning the local dispatch index X and Y will be filled in with a value we want to use, which is not what you want when you want to turn an index into when you go into an index in Morton code space back into a two-dimensional coordinate. So it's basically ordered in a Z order. If you're not sure what Morton curve is, just search in Google and you'll understand it. So when we go from the one-dimensional Morton to the two-dimensional Morton, we need to go 0 to 63, and that'll do an 8x8 basically. So that was one problem that we had, but I also didn't change the code down here. When it came to, there was this destination coordinate, I had it as SV dispatch index, right, .xy, which seems alright, but again, within the thread group, the X coordinate would go up from 1 to 63. That's why when the image looked very wide when it was in the image in the texture viewer. But now I take the local index and I turn that from a 1D more coordinate to a 2D one, and then I basically put it on the group, on the dispatch group as well, and get the actual proper destination coordinate for the pixel. So now when we run it, we actually get the downsampled bloom texture image, but it is actually going to be a bit wrong, and we'll go into some of those things in just a second. So here's our bloom texture. If we turn the brightness down to something, or the white levels down to something acceptable, well, whatever. Now we change the MIPS, you'll see that it gets lower and lower resolution, and you'll see the bright bits, I guess, will stay around a bit. But yeah, this is something what I've got to improve on though. So the implementation we did was a little bit wrong, and we'll go into that, because the slides are a bit ambiguous, really trying to work them out exactly what they meant. So also to note, this black area here is completely okay. It's just because we've rounded up to the nearest power of 2, so when we half it, and half it, we don't get an odd number and have to deal with that. Although we must be careful around these edge pixels because they are making it a little bit transparent or something, so we might, yeah. I think black's fine. yeah, I hope everyone's having a good week so far. Welcome. So, right, first off, there's actually a learnopengl.com tutorial on those slides I was looking at. Those Call of Duty next generation post-processing slides. Oh, for crying out, I didn't want to save it. He's asking me too many things. Yeah, I was looking at this sort of next generation post-processing thing. This is where it comes from. Now, there's actually a tutorial on learnopengl.com that covers the same sort of thing, but it actually has code. And it's supposed to be a lot easier to understand, because this is what we're struggling to understand, is what does this picture mean? And I did break it down, but it was a bit confusing when it says all the weights add up to 1. So it made it seem like you only had to do like 5 samples, because they were bilinear fetches anyway. But it turns out that's wrong. You actually have to do 13 fetches, and then 30 bilinear samples, and then join them together with that weights divided by 4 and doing a weighted average thing. So yeah, turns out it was right doing it that way around. So what we're going to do is we're going to implement this down sample from here, and then we'll implement the up sample, see what the bloom looks like, add any additions to it, like, because there's some improvements to make it that are down below, but also probably some in the slides. And then we'll try and optimize it by only sampling we'll try and optimize it by making it such that we sample this sort of grid pattern once, and then it will share it across the neighboring pixels that overlap it, basically. So let's go ahead and get started on getting this in. So we go to so I guess we'll comment out this one for a bit. We'll do this later. Yeah, we'll do this one later. We'll change it. And let's just do a new one. So the basic idea is we would like so it's saying within the plus x plus y, what is x and y? Source texel size. So this black area is the one maybe the slides are going to be useful still. So we need to get, so if we get in the center of this one here, then we should have to just add a texel basically at the source texel size. Yeah. Right, so this is the destination texel we're trying to fill in, and we're going to take all these samples at these locations here on the corners, right? So the destination is the bigger grid, the source texture is the smaller grid. Since we're downsampling, right, we're trying to downsample. So we need to calculate. So I guess we still need this. Destination coordinate, and the source coordinate is that times 2. And then we're going to add, and then I guess we add 1. The source coordinate put us down here. We could then add 1 to get us there. If we add 1 to get us in the middle, then the rest just come easy, I think. Well, Yeah, so let's add one to get us in the middle. Like that. So now we just basically yeah, so we'll just do it this way. So yeah, we could pre-scale it down. And then all we need is an offset, a text size basically. So let's say source UV. So it'll be a divide source coordinate. Bear in mind that we cast it into a float vector. And we're dividing it by the dimensions of the source texture. Probably as well cast it into that floating point vector as well. Okay. Cool, so now we've got that location here. So our UV is, so from 0 to 1, right, so in the UV space, we've got this coordinate right in the middle now. So we need to now produce a sample for here, here, and here, and here, right? And so I guess we can start with those. So yeah, we get this sort of like texel dims UV space, right? So that would be basically 1 divided by source dim. So it'd be like basically copying that and then put in an S at the start. So scalar on the left. So now we can reuse this. So if I did it this way, it'd be slightly more optimized because we don't keep doing a bunch of divides and stuff. Because we're going to be, because I could have done it in coordinate space and then divide it for every single sample, but so this would just be slightly better. Because I want it to be fair when we do a more optimized version and then compare it against this one. So this is a bit fairer. So we can keep with the OpenGL, non-OpenGL examples doing where it does A, B, C, D, and all of that. It would be nice if we could document it with some kind of like thing like this. That is for sure, but we'll see what we get. So here it's doing like 2 times whatever, right? Or X, Y sort of thing. Makes sense. So I guess you could call it I call it TDX. Let's just call it TD. Sure. Okay. So we produce like an A. So it'd be from the sample texture at that specific MIP level, yep. And now we just need to produce. So I could do this thing, right, where we just say define sample, and then we literally just put in the UV, the X offset and the Y offset. Oh wait, not really the UV actually. The X offset and the Y offset. And then we can literally just produce this, right? Okay. And all we're going to do is just say add. So from that source UV, right? And then we're adding like a TD dot X multiplied by X offset, right? And that, you should really put it all in brackets just in case, right? It's macros, you know. They'll bite you in the butt if you don't. Because you'll come along later and be like, oh, I'm going to change it. Or whatever. Or copy and paste it to a new place of code and then change it. And then it just has a bug and you're scratching your head for ages. Right, and of course, in the macros, it doesn't. figure out the brackets. So I've got to manually check them for some reason because the language server protocol, whatever, breaks down. Okay. I think we're missing an extra bracket here. Cool. So now all we need to do is just literally write sample, and now we can go full ham on this. So it seems like they're doing a similar thing, but with like times 2x and all that, right? And sometimes they don't offset it. There should be one where it doesn't offset it at all. Yes, this one here. They call that E. So that would be this, yeah, that one there, E. So I guess we'll give it the same alphabetical namings, such that when we do this, it makes the same sense. But bearing in mind, though, theirs might be, well, they're an OpenGL. So I think OpenGL is bottom left, whereas mine is bottom left as well, actually. OpenGL texture space origin. I think it's bottom left. Yeah, lower left corner, great. I kept that in mind, even though I'm in Vulkan. I just flipped my texture at the end of the, when I present it to the swap chain image, or when I copy it to the swap chain image, I flip it. Because, you know, top left is, yeah, I don't think it's as good. I do like the bottom left origin. So, right. There should be, there are ones with ones, that's good. So they do like a -2. So -2. Did I do the unary operator? I think I did. In my compiler, then a +2. And we call that 1A, yeah? So, alright, we're just going to copy all of that. And so we need to go up to M apparently. Oh no. Oh yeah. Well, that's interesting. So they label it A, B, C, D. So the 3-row ones are like that. Okay. Rather interesting. I wonder if we can, because I've got to figure out how do we map this into like the LDS memory, and how do I organize these? Well, so it might give me some ideas. Because if we're going to optimize it, we only want to fetch the samples which are going to be used. J. Okay, you know, this kind of is a bit. Should I just call it S0, right? Yeah, I want to break it. Let's just do our own thing. This is the way. It's a bit clearer what comes next. Alphabets are them, you know. Okay. So they do like a. So that is a plus nothing. Then a +2. Then a +2. And then a minus. So we're on D now. -2 minus nothing. And then a. Then a -0 -0. Sorry, +0 I meant. But whatever, same thing. And then for the F1, that is +2 plus 0. 6. So we're on a new one here, so it's -2 -2. Hey there, Taylor, how's it going? Welcome, sir. How's the engine coming along? -2 +0, I guess. So we want -2 +2. Alright. Now the final ones are just +1s basically. So they're... Crap, I need 2 digits. 10, 11, 12, 13. There's the 13 samples. Bananas. Doing well. Been doing a bunch of Soulcall related work. Awesome. Have seen/tried Soulcall. Yeah, the cross compilation thing for shaders, right? Yeah. How does that work? Never tried it. But yeah, Soulcall's pretty good, just for most things. The world of graphics programming got really complicated. And it's all because they didn't tell you what the GPUs are like. Or that information is like not as widely taught as, as computers are. Interesting. It's like you write a single file in a particular way due to cell style, and it compiles and generates a number of bytecode blocks and defines it in places into a header file. Right. I guess it's heavily like macroed. Like they use macros and stuff to do a lot of things, right? Or if they got their own sort of like... Yeah, they got their own little like transpiler basically, isn't it? Because you can basically like that's a lot of the a lot of the big engines do it, I think, is they basically have they will like, some of them would basically have like a bunch of macros to do stuff which is different on each platform, and then use some subset of all of them to like all of the different languages, to use a subset of that to make it transpile to the other ones. Yeah, the whole sort of shading compiler stuff is just all, it's just all crazy. -1 + 1 +1 + 1 minus minus plus. Cool, so there's our 13 samples. Now I guess we can combine them all. And yeah, take a look at our image. It should actually be much better this way because it does it properly. So apply the weight. Yeah. What the hell? Why is C? The way they've done this is not confusing at all. They use the at symbol to have the extra markup, tell the transpiler to do things and replace uniform types, urine types in the header. Right, okay. Right. Yeah, it's both my least favorite part of graphics programming. Right. At least favorite and favorite part, right? Yeah. Yeah. You know, because here's the thing, right? The GPU is really cool and you can do some really cool stuff on it. But also to try and do the cool stuff, it's like this weird thing which like it sucks to try and make it cross-platform. And you know, to understand what the hardware does, you have to like really look into sort of like these PDF documents or whatever online, or the information is really scattered and stuff as well, and then like when you're trying to actually write some code for that sort of hardware or whatever, you're going through all these like abstractions and stuff. Uh, it would just be so much better if it was more like a CPU, right? Or you program for the hardware or something. And actually got like a proper compiler. You know, it's awesome assembly. You can like see the assembly in like in some tools and that, but again, it's just super indirect. And I don't see that world changing anytime soon. Yeah, secret handshakes, that's a good way of saying it. Yeah. Hey Lupo, welcome sir, welcome, welcome. How are you doing? Hi, hi, hi. How's the week going so far for you? So let's combine all these samples and whatever. So what I'm going to do is decorate these in the ABCDs because I decided not to follow that. Hang on, let me get back there. Right, A, B, C, D, A, F, G, H, I, J, K. The favorite bit, right? L, M, N. Then there's no OP, but anyway. The bit that everyone rushes. Oh crap, I missed a character. A, B, C, D, E, F, G, H, I, J, K, L, M. What did I do wrong? Did I forget the alphabet? A, B, C, D, E, F, G, H, I. Ah, yeah. Yeah, yeah. Uh-huh. I've got an extra sample there. Oh wait, I've got 14 samples. Right. Somebody, I.e. me, messed this up royally. Which one is the duplicate? The cold is coming back. It's been warmer for a few days. Yeah, that's true. Nice note. Yeah, similar kind of here. It's got a bit colder. It is a bit cold. I don't know why vendors make it so hard to get assembly output, even if it's not a one-to-one that runs on the hardware. You would think that it'd make it easier for devs to optimize for the hardware, but still, NVIDIA CG compiler built 2012 to catch and that's stupid image of cell, right? Yeah, AMD has their, and here the Cranston has going. AMD has their sort of rad. Is that what it is? I don't know. They have their open source compiler on Linux available. I downloaded it and then I ran it and it crashed. And I was like, but this is the one they use in the driver apparently, but I don't know. It crashed. And I thought I would get somewhere with it. But yeah, so that was a big shame. But it was only available on Linux by the looks of it. I forgot what it was called. But yeah, so the other way of doing it is you got to go through their tools. And, it would be really cool, right? But they don't want this. Is, AMD is all like, hey, we're GPUopen.com. Look at us. We're we're on your team, guys. You know. But if they really were GPU open, right? And I love these guys. I love the things they do. But if they really were GPU open, you know what they allow you to do? Compile your shader code to their instruction set architecture, which they say, which is here, right? RDNA 3. I suspect you can see it. It's right here. You can read it, right? Blinding your eyes and everything, but you can read it, and you see all the instructions and everything. And then you'll be able to load it into Vulkan, right, and run it. But you can't. So, yeah. I love the things they do. They make a bunch of open source stuff for engine developers and stuff, right? So what MIT license is cool. But just allow us to just feel like we're writing for your hardware and not going through so many layers of abstraction. Just bananas. Paint install though, like you're right. There's a lot in Mesa. They just don't expose it in still unexecutable, right? Yeah, so you can. There is that stuff in Mesa, and you can like install the developer driver and then like get access to the debug stuff. So if it crashes in the Vulkan code, you got debug symbols, and you can like hop in and see like stuff or whatever. I don't know, but yeah. I haven't bothered doing any of that. And there's things you can feed in, like there's environment variables, which I've used in the past, where you can like put in these like you can basically say, give me just dump all of the shader compiler stuff. And we've been using that to get the number of VGPRs that have been allocated and that. And, but it's just not really a great workflow, but you can do it. So it's all there. They just don't expose it. And, imagine this, right? You download this Vulkan SDK, right? Software development kit, right? And they're like, and they've got all sorts in there, compilers, right, to SpearV, all these SpearV tools and stuff, right? But where's the SpearV tool that gives us AMD source code, right? Where's the SpearV tool in this SDK that gives us RDNA source code from a SpearV file? Like, why don't we have that? Why do we have to go to AMD and get their like tool, which doesn't really work on Linux anyway, and it's pretty heavy. Then you have to sort of run your application, then it sort of introspects your Vulkan calls and gets the thing, gets the binary and does it that way. Well, I can't just have the file on my computer. Stupid thing. Did AMD used to have trash GPU drivers? Yeah, the drivers are sometimes a bit hit or miss. I had an RDNA 2 card, and I don't know if it was in my card that was a problem, but when it got a device loss, it'll like bring down my whole desktop environment. But I've got the RDNA 3 card, and it doesn't do that anymore. So I don't know if it was the card or the architecture or the driver they didn't bother fixing. But I think George Hart's had the same problem. Yeah, they call it GPU open. But they do good stuff, but they could go further. I remember there were some laptops with AMD GPUs, and they said that they had some software issues, but I didn't see any laptop with AMD GPUs besides GPU. Right. Mesa has -E tools all build option, which gives you some standalone compilers, right? But not for the major vendors. Oh, weird. Because we kind of nice things, exactly. I know. I'm kind of happy you're frustrated too, to be honest. Means I don't miss anything obvious. Right. Yeah. Yeah. I don't know why they didn't do it. Like, they've got so many extensions in Vulkan. Why can't you just tack onto that P next thing a pointer for AMD RDNA source code? You know, and then like you've got another structure that points to the source code for AMD RDNA cards. Like, what are we doing? This is so stupid. There is a Godbolt client site that has all the GPU compiler tools. Can you link that at all? Oh, I'd like to see that because I've seen one, but I've seen that for like slang and DXC and GLSL-C and shader-C and all those things. Not like awesome. Thank you, Cranston sir. Appreciate you. Appreciate you. Which one of these is a duplicate? How was I thinking with that one? Okay. -2, -2. Cool. I, J, K, L, M. There we go. Right, it's plop. Alright, let's have a look. Yeah, I think this is the one I was talking about, but maybe they've added more. Right. You can have it local. If they've got it here, you can have it local. Right, so you can put it in SpearV apparently, right. Okay, so maybe they have a tool for it. Radeon GPU Analyzer. Only on Windows. No, I think they've got it on Linux. Yeah, so I think I tried to download something like this in the past, and then it crashed. Yeah, it does replace OpenGL, but how much have you done like a 3D game in OpenGL? Like, about what sort of passes you need in a full render and stuff like that. Right, it's infinitely big file size. Great. Just keep going then. Well, we'll see when it's done. Now let's look at my face. Cool, so let's just plug all this in here. All right. Yoink. So this is color. Color. Right, downloaded. See, but be able to chuck my binary into it, like it will crash. Done it before. Yeah, this looks familiar. Put in the workbench. So damn big. Probably full on, LOVM compiler. Oh. Okay, well, luckily it just didn't dump it all in there. And what do? You open up this. And you gotta figure out which one it is of all the 17 executables they've got. Oh yeah, they're giving you the whole suite, isn't it? So there's like a GPU analyzer bin. Oh yeah, I remember this. And then it was like... Right, let's give it a compute pipeline. Take it. Oh, for crying out loud. What is this? AMD tools and dark mode. Right, single click. So, it's in the build, right? Can it deal with my mega SPIR-V file? There you go, see? I crashed the compiler again. They might not like my SPIR-V I've computed, even though it works in their driver. So, I don't know, try and chuck some GLSL in there, maybe it'll work. But this is another problem I've had writing my own compiler, is that whenever there's a driver bug, I've got to change my thing. And, you know, how do I debug this? Well, it's simple. You write the smallest shader file, see if it works. And then just like basically just delete as much of it as you can and see what will work until you find what the problem is. But yeah, I can't bother to do that. Yeah, maybe this could be the tools to use. But yeah. It's a bit weird it's a GUI though. Too good at SPIR-V, I don't know. Yeah. SPIR-V is kind of alright, but you know, it's, yeah. Anytime stuff will get fixed in the driver is when one of the big compilers has the problem. It's a bit like if you got a problem as an indie game developer and you write your own Vulkan code, like, you know, you're gonna have a good time trying to get hold of a driver engineer as an indie developer. But if you're a part of a AAA company or using the Unreal Engine, you know, sure you get some help. Do I dream in C? I don't really dream about much programming really. Sometimes if I'm like really stuck on a problem and I'm like fixated on it, I'll dream a bit, but I don't really dream much about programming. Not anymore. Like, I may be behind the times, but I just want a CLI that takes OpenGL and spits out as in file or whatever. Yeah, you'll nat all the SPIR-V file, right? And then you can just chain them together. It doesn't really matter. But yeah, maybe there is a CLI tool in there. You just got to dig through and find it because it's got to call it, right? So that open will presumably call that. Yeah. So then it must be this RGA bin, right? And then RGA is like this wrap around it for some reason. So you could probably do like RGA. If I did that. There you go, -H, and then it's probably really undocumented. Yeah, I think this is what it is. We chucked into here and it just complained. Like, what sort of compiler is this, right? Wait, before I just trash on it. So I put in the -S VK sphere V off LAN. Right, okay, now I've got some options. So I guess you put the input path. It might only really want one shader per file because that's what languages basically do. These compilers basically do, and I've got multiple in mine. I've got multiple entry points in mine. That might be what the problem is, that like it cannot find an entry point, or maybe, I don't know. Yeah. But anyway, let's say I go and wrestle with my compiler to get it to work with that, which I cannot bother to do. Ideally, they would just support the SpearV spec, you know, not have bugs, but we can't have good things. Right, so E, whatever E was, E is S4. We'll check that. Yeah. Right, let's get this down sample done. Yeah, why can't they ship that tool in the Vulkan SDK? That's my next question. Like, if they put that in the Vulkan SDK, right, it would mean, like why don't they? They have all this, like, hey, we missed the GPU open. It would just be good, right? Alright, so just gonna do a bunch of ads. Yeah. Okay. So there's 3 ads then. Okay. Cool. And then multiply to compute the weighted average basically, and then it's summing. So I need to sum the final result. Alright, so now we've got to get these ABs and that the right way around. So it's S00. For that one, C is S02. G is S06. I is S08. Alright, B is S01. D is S03, right? Yeah. S07 for... No, S05. Okay, that's right. H is S07. Cool. M is S12. L is S11. K is S10. S is S09. S09. Cool. So apparently we run this. We should be seeing the proper bloom down sample now, which follows this. I'll drop a link in for it again. I found an OpenGL tutorial on this Call of Duty post-processing Bloom thing. So they got actual code examples, so it's a little bit less ambiguous what's going on. So I'm going to do a more optimized version of this later on. So now we do the upsampling. It actually has lots of good context in here. I read the whole thing in my lunchtime today. Oh man, I really need to start learning Vulkan. Because of legacy, we don't make the switch to Vulkan in my team. We didn't make the switch to my team in Vulkan yet. Right, fair play. Right, so you got like a, was it like a 3D engine in Vulkan? Oh, sorry, in OpenGL at the moment? Is it for desktop or mobile or both? Okay, so the upsample is, oh, sorry. We'll do that in a sec. Let's get this running and just take a look at the results in the... Right, I did a thing. Hang on a minute. Brackets and stuff. Cool. It's CAD software actually. Nice. The only real time when the camera is moving. Awesome. Is it like a private tool? Like, or is there like a link to it at all in any way? Right, so Bloom. So let's bring the top down into here. Or the white level. Down to something sensible. And let's look at the downsample image. So the thing is we're not, well, wow. Black pixel. It's not good. So it is downsampling, but that's going to stop affecting getting bigger and bigger. Oh, they had a link about that in the, they had a thing about that in the bonus section on this article actually. You sometimes get a black pixel because it actually, you're multiplying a zero on a zero or something like that. Right, okay, I think that's right. But yeah, so we don't actually see it that much because we don't have a very bright, so what we're going to do is actually go into the graphics. We'll find the lights, right, hard-coded lights. We'll up some intensity to actually be like 50, right? And now when we run it, we might see some more sort of like, okay, they're quite bright actually. So take a look at the bloom now. Move the white levels down a bit. So when do they kind of cut out? About 50, yeah. Good, that's great. So when we do the down sample, it should now actually preserve more. Maybe 50 is a bit too much. Maybe it's fine. But yeah, we didn't lose any there, which is interesting. But we had those black ones which appeared. Those black spots which appeared. So that's rather interesting. So let's see about that, because down here it says in the bonus section this. While the bloom effect wasn't working nicely, I observed some multi-black boxes. In test application, I was working on blue. Right. So open up render doc, which I can't recommend at the moment because it just crashes on my PC. I don't know what I did, but yeah, that was sad. But we try and zoom in, which we can do simply by some of the other downsamples. Right. That's clear what's going on. The first downsample yields some pixels which are exactly 0, completely black. Yeah. So why does it happen in this downsampler though? Like what is it that's causing that? What's S4 is also when you output the oh right, so when you take the weighted average of a sample and the sample is black, completely black. No, so you're adding all of these together, multiplying. Yeah, I don't get it. There's still we need to clamp the result of the first downsample to some small value greater than 1 so we avoid doing any multiplications that yield 0. Why the first one? So if you had a completely black pixel on the first one, and you'll put black in, right? Hmm. So maybe we just add, let's give it a go, right? Maybe we just add 0.00, see if that fixes it. Then you'll have a bit more on the alpha, isn't it? I gotta be careful. Right, let's try and see what they're doing. So it's like a max S color 0.000. Let's see if that fixes the problem. A very big company. Actually, don't out me. Let's say I like this company software and I've been using it for a very long time. Software's been used in a very long time in the gaming industry. Right, okay. Right, I have an idea of what it could be. Have you tried getting a new PC that doesn't crash render dock? I don't even know. See, my PC's got kind of old hardware, but it's not that old. Like, I think it could just be the way the certain passes I'm recording. It could also be my custom shader compiler as well. It's broken in it. It did break in it before, and I messaged the guy, and he fixed it like literally a couple hours later. I was like, wow, top guy. So yeah, I don't think we're seeing those black spots anymore, which is great. Okay. Still, I don't understand how. So a black pixel from the. So in here, if we had a completely black pixel, basically, it would then. Yeah, I still don't understand that. Obviously, it'd be 0 multiplied by the weight, right? But you're summing it. So there should be a non-black. I don't know. Or is it because you end up doing a bilinear sample? But again, that's like a lerp, so it should, yeah. Anyway, let's just leave that in there. Cool. Let's move on to the upsample. So make a new shader. So after you've downsampled, you then upsample and do another type of filtering on it. Okay, so we'll also go to graphics, find the bloom. Bear in mind we also forgot to put in those scopes, so we'll plop those in there as well, because in the profile, when we go and look at it in a bit, we'll be able to see how long the bloom pass takes and, you know, improve it and make it go faster, which is what we like. So now all of those dispatches will basically show under this sort of bloom section, so that'd be cool. So, oh, did I delete the other one whilst I made the new one or something dumb like that? I did, didn't I? What a top lad. Right. So this time we want to go the other way around. So you kind of need like a reverse for loop. So I guess you could just say like mip like that. And then you want to go from, so you say source mip equal mips count take mip. Or I could just call it like index, right? So the source, so that we take, yeah. And then the destination is source mip take one. Nice. And then it's all just basically the same sort of thing, I think. Destination, yep. And then we're launching the up sample one instead. Cool, so they all obviously will go one at a time. There'll be a barrier in between. So in the future, when I want to optimize this even further, we'll probably do a single pass, right? Very specialized single pass upsample and downsample specifically for bloom. But it's not a problem I want to solve, because although it would give us a performance increase, it won't be like, it's not the easiest, and two, it's not. We might save like all in all 0.3 milliseconds, right? Which is still good savings, but it's not something I want to particularly save right now. That was just a guess, by the way, but it's just to show, give an example. Okay, we're working on blue. So working on this, doing this sort of tutorial here. We start off with the slides from the Call of Duty. This is where it comes from, basically, is the post-processing, next generation post-processing in Advanced Warfare. There's a bloom section. They've got other things in here as well, but we're trying to implement this. It's pretty cool implementation, I think. Produces more sort of realistic blooms, like glows and things, basically, right? So when you have a bright object, we should get like a nice little glow that happens around the object. So it happens by basically downsampling the image, right? And then you're doing some sort of like special, a sort of like a 6x6. So for a pixel you're trying to shade, you're going into the resolution, the higher resolution that you're downsampling from. You're doing a 6x6 sort of blur basically as you go down, as you downsample, and then when you upsample, you're doing like another type of blur, something like that, whilst also merging the color result or something like that, I think. So this is the Gaussian blur distribution, isn't it? Right, and it's was kind of a, I think so. Where's the merging of the color? Oh, that's done later, isn't it? Maybe. Oh well. Interesting, got like a filter radius. Right, so an accumulation with a blur. Yeah, see there's the plus. Rather than D, and that is the color attachment. Yes, yeah, let's just read this over. I wanna and my on E have blooms of their own. On a HDR, monitor bloom is probably unneeded. Right. It's interesting. Yeah. HDR does get proper bright, doesn't it? I don't know if they run into the G buffer. This is after G buffer's been composed, isn't it? So, yeah, let's read this bit. I'm a little bit confused. The upsample works the opposite way. Progressive blur and upsample. Wait, how does the downsample work? Why do you not call it a blur? There's a special blending. Because you are essentially taking the information and you're taking, you are essentially blurring it together in some way. Or filtering it together at least. But I guess it's not doing it's kind of similar anyway, so, but it's in the upsample instead of a downsample, right? Using letters A to E. So it's doing a smaller one. There's probably a better image here on it. So this is the downsample, upsample. So there's a sort of like tent filter thing. Right, because they're doing it in a pixel shader, they're probably using like additive blending. Is that what they're doing? So when they launch their, because they're doing it in a pixel shader, isn't it? So there's probably extra magic going on. We read this. So bloom, texture image, you know, to make it extra confusing. Render down samples, render up samples, right? All right, let's have a look. Yeah. Okay, so they basically they do additive blending. So that's where they're doing the ad, right? They're not doing the ad in the shader. When they write the pixel out, it's like, hey, what's the previous pixel? I'm going to add it, right? So added to what was previously there when you downsampled it, probably, and that's what we've got to double check. Right, so let's read this. The upsampling shader works on the opposite way, progressively blur an upsample from the previous figure using these letters A to E as follows. So E quote, whatever you call that, equal E. This means that we blur an upsample using a 3x3 filter kernel. When we perform the second line, we have D bounded as a target, color attachment 0. What is D? And we sample E and do 3x3 kernel around the current pixel. We do a using a B4 as radius. Right, so they changed the radius, that filter radius. Okay, so it might get wider. Maybe it starts off as being wide and then it gets smaller and smaller or something like that, or the other way around. Right. B4 is radius and spread out the lookup texel positions. An important detail is that we need a different radius for each upsample and the larger radii on the larger MIPS, so that using a radius in texel space, the radius will automatically grow during the upsampling procedure. The upsampling fragment shader is shown here. Right. Remember that it's a bilinear minification filter for this texture. Right. Remember to use floating point HDR, we've got that. Use edge clamping for this texture. Right, so for the other one, what did I use for this one? So maybe I got my samplers wrong as well. So they've been explicit about it in the second one. So we can actually just look at the code below. It'll tell us. So it's render down samples. So that one doesn't seem to be doing anything special. Right. So the time when they create it, they do a min filter linear, mag filter linear, right? So that doesn't change, obviously. And then a clamp to edge. So we're on clamp mode. Yes, that's what we're doing. So yeah. Okay. Well, sure. Maybe this one needs it. But yeah, we're doing that already. Okay, good to know. So anyway, we need like a filter radius to be passed in, basically. So let's get that ready. Anything to do with this sort of thing that we can read? So progressive, upsample, and sums the chain as use upscale as found in this reference here. We filter during upsample on the flight as in the downsample case. And use a tent filter scaled by the radius parameter. Was not mapped to pixels as was in it. Beta convolution coverage to a Gaussian. Simple and fast. Right, I wouldn't have been able to figure out what this meant. Not gonna lie. Well, I could have worked that out, but it is still a bit ambiguous. I still want to know if I got it right or not. Like, it's 3x3, right? And then you obviously got to do this sort of maths here. But it's just knowing if you got that right or not. So the center pixel gets 4 times, right? These ones get 2 times. And that one gets 1 times. And then you do the weighted average there, because that all adds to 16, right? So I guess I could have got that. And then there's this filter radius thing, which is applied right on how far do you step in UV space. Right, gotcha. Okay. Not rocket science, but also it's like a non-square image, right? But it's a radius. Okay. Gotcha. It's not rocket science. So anyway, can you work this out based on the MIP level? Because we got that anyway. Or this is configurable, isn't it? Is that what we're saying? So you pass it in when you say render up samples, right? So you go a render bloom texture. Is that just something? Okay, so apparently that's a configurable value, although this filter radius must be, it's in UV space, right? It's like a constant. Yeah, something smaller, 0.005. Okay. Right. So I guess we'll keep that, it could be programmable. Why don't we make it programmable? So I literally just do something like this, right? Filter radius. I'll put in my settings thing. G settings. Graphics bloom. Filter radius. Right, we'll plop that in. So settings ENC. So we'll have like enable bloom and all that in a bit, but bloom, filter radius. Now, if we provide like a 0 to 1, right, range, but then we change it by just scaling it basically, right? So it's always good, I find, to sort of like expose settings to the user or to the person making the game, right? Give them a 0 to 1 range or a -1 to 1 range, whatever makes sense. It's norm or unorm, right? But then what it actually maps to under the hood is something different. So they suggest about 0.05, something small like that. So let's just say at most a 0.1, maybe. So we just multiply by 0.1 since it's, 1 will map to 0.1. Yeah, so that gives about 20 different values. Well, if in increments of 0.05, it's 20 different values, but it will be more increments than that. I think 64 of them in the settings thing. So yeah, that'd be pretty cool. And all we have to do is just regen the encoder stuff, because that's a code generate file, and then we just have to simply just put the filter radius in, and then cool. Now we can go to the shader file and start writing all the code. So the idea is we've got to do this sort of summing thing, right? So it's the previous downsample, basically, right? So for that pixel. Then you're summing it. Right. So that is actually going to be a read write destination texture. So you're actually going to do a load and then you store it. So color load. So destination coordinate. Okay. You do the load. You do all your texture sample things. So I guess we'll do a similar sort of thing to this for now. Get all your super lovely samples. I would have expected that for some fixed number of samples. The radius would have been completely determined so that you're sure you're sampling neighboring texels. Yeah, I would think you are, right? It does seem a bit weird that you get to... So, it's fixed. But, yeah. I guess we can read it again, but yeah, it does seem a bit strange. Because I remember it saying, like, as you go up the samples, the radius... Yeah, let me just read that again. The whole detail is that we need a different radius for each upsample with a larger radii on larger MIPS, so that the radius... So by using a radius in texel space, the radius will be automatically grown by the upsampling procedure, right? So, but that only makes sense. So source texture. Yeah, so I don't know. Yeah, that's something to keep an eye on, actually. Yeah. Yeah, I guess you would not want to either. But I guess it's a way of like, you want it to be very small, isn't it? You want it to be like the size of the size of a 3 by, of at least a 3 maybe, 3 texels, somewhere in between there. But yeah, so I think the bit that's confusing is like when they set their texture at that mip.texture, so they got a text for each mip chain, right? So I guess they set this up here somewhere. So for all the mip chains, they create a texture view, right? Okay. So they're getting a sample texture for each of those. Okay. So that's the funny thing about it. Yeah. The effective filter size does get larger the more MIPS you compute, I guess, but yeah, the experiment thing is a bit strange, but let's see what this thing says here. See, they're a little bit hand wavy here with it, I guess, as well. Scaled by a radius parameter. Okay. I don't think that's anything relevant. to that filter radius. Scaled by radius parameter. The filter do not map to pixels has holes in it. That's interesting, right? It has holes in it. Very vague. The notes don't show anything either. But yeah, we can have a bit of a play with it at least. We've got it in a piece of UI now, so we can have a play with that. But the thing we've got to be careful about is when we assign that sample texture, we want to assign the sample texture of a MIP, of a texture view at that MIP level. So if we do GPU resource ID offset, right, and perform the ID offset to get the texture view, because I create them all one after the other from the texture IDs if I create a bunch of texture views. And so we did plus the source MIP, then it means that that UV will grow. So we don't have to change this distance based on the UV, and we'll get it automatically, I think, but we'll see. Yeah, interesting. I don't know what it might add some weird effects though. Yeah, strange. Okay, so let's try that out at least. So we didn't. Okay, so back to the upsample shader code. So we've got this sort of like filter radius. So I guess we can just do something like radius BC filter radius, yeah? And so do a sample based on some source UV. I've got to get the source UV as well. Get a bit of source. And that's the offset, that radius, yeah? So you're adding whatever that X off and Y off is. Now you're not doing this sample MIP thing. We'll do MIP 0 because the sample texture is already a texture which points at that MIP. So when you do another MIP offset, it's going to go even further, but it's got a texture view of only one MIP anyway, so it might clamp the MIP, to be honest. But anyway, just to make it more correct. So there's, in the upsample, there's still 9 samples. And I don't think you can optimize this one by pre-caching into LDS memory because the filter radius is not at a pixel level, it's kind of ambiguous. So yeah, I guess we'll put in. So yeah, I guess you can do something like a minus radius and a plus radius, right? So something like that. So they do their ABCs and stuff. Bear in mind, which I could probably delete that from the other one. Don't need that there anymore. It's just me trying to. Okay. So they go up to F, G, H, I, 6, 7, 8. So there's a plus a 0 here. So where are the zeros, right? So there's another 0 at E. And then, they're on the X's? Oh no, then the zeros are all the Y on. Okay. That'll be like another one there. And then these D. There you go. Right, so minus plus, plus plus plus, and a plus there. Then a minus, plus, for crying out loud, what did I do? Plus, and I guess that's a plus as well. And I guess these are all minuses. Yep. Cool, so you got all your samples, this undef sample. And now we do this super lovely weight thingy. I should have maybe actually kept those A, B, C, D, E, F things, but oh well. Let's just keep that for now. So okay, so I've got to point F these things, because if not my compiler cries about it. Right, so I'm going to sum all those. Wait, mol S. And then okay. Oh, what am I doing? So multiply equal multiply. Cool. So we've got to be careful because we've sampled the source color. This has got to be, so from the destination, we've then got to, before we overwrite it, we've got to make sure that we sum it on at the end. So upsample equals, well, maybe I can do something like this. Before we store load, so maybe that'll be equal to color, and then we'll do something like a color equal add color that. Then these are simply just color, and this would be color equal add color with what the pixel was before. So you're blurring the lower resolution image. So you're sampling the low resolution image at some offset based on that radius, blurring the different samples here, loading the previous pixel for this that we're writing to, and accumulate that onto it, and then store that back out. Okay. So we're going to do all these sums here as well. Cool. Bunch of adds. Nice. Okay, it's looking alright. So should we try that out and see what the result we get? So the problem is after this, we've got to somehow like integrate it into the actual scene image. So that, I think you just apply it on top. We gotta be careful though. So let's give it a launch to see what happens. Oh yeah, what to remap these. So E is 0s4. B is S01, D is S03, F is S05, H is S07, A is S00. Oh no. So 2. Or was that G? SO6 and SO8. Nice. So let's give that a go and see what we get in the texture viewer. So here we go. So we're going to move down to here. Texture viewer. Bloom texture. Now oh, okay. Clear problem already. So we've got all the history here. So we can see it. That's when it gets added in. We change this here. So we go to like the lowest MIP or whatever. Second lowest MIP. So yeah. So yeah, as you would expect, right? This one gets written into when this shader's called, but it's a bit of a smaller resolution, so I think we got our dimensions a little bit off. Or something like that. We shall see. So we go to the graphics side of things. Right, so this thing here where it does the upsample, we get the destination is bigger, right? So it's one less than the source one. Is there a sort of reverse? Yep. So those are okay, I think. Okay. So we dispatched over the... So you're dispatching over the source stems, is that right then? No, it must be destination, right? Ah, okay. So in my shader, what I'm doing is I'm saying right. So the source dimensions will be divide by 2. Do we need to add 1 to get it in the middle? So if the pixel is bigger, yeah, so right. So when you do a divide by 2, there's a good image that we can look at. So this was for the downsample, so it's the other way around. But so it'd be this. It would now be the. So we're trying to shade this sort of light grey lower left one here. Or I was trying to say this one here, this one with 0.5 in it, this box. When you divide it by 2, you'll get this location here. Right. You'll snap to this one here. There's this big black border here. So if we want to get in the middle of that, it is offset by 0.5 in this space here. So add S 0.5. Okay, that'll be better. Right. Good, good, good. So let's try that out. Okay, so we're seeing, like when we view this the initial texture, this is what it was at the start of the frame. So it's like we happen to get the same memory allocated or whatever, and then it gets cleared. So this is the one from the last frame technically, so what we're seeing is the final result after the bloom, right, being applied here. So this is what it's like before, this is what it's like after. Before, after, before, after. So yeah, this is what the scene... So it's generally looking brighter, shall we say. If we get this down to 1. Yeah, so this is how it looks. It's similar to this image here, where this is just the main render. We're not actually applying the bloom to it. And now when we write the final upsample from MIP 1 to MIP 0, it brings up the whole image has got brighter, and I don't know if this is what it should be like. This is definitely looking blurrier here, right? Well, as in the bright spots have definitely widened and stuff, but like I don't know how we're gonna supposed to. Yeah, we're gonna have a bit of a think about it still. Maybe this is okay. I just got to think about it. So afterwards, you need to blur it. You need to apply it to the main texture, right? So write in the program, and I'm talking about this OOP stuff here. So there's a full source code here. Oh, this ain't the help, is it? Oh, it's full source code, eh? Right, so how are they applying this to the main sort of like image, I guess, is the question. Is it just an addition? But then if it's an addition, then it just means it's going to, overall the scene's going to get brighter. Just rewrite this in x86 assembly. Okay, I'll start tomorrow. Well, welcome, TY. So where's their code that renders the sort of post-processing thing? Bloom is disabled, blur. Bright fragments and 2 Gaussian. So they've got different bloom, unthresholded bloom. Right, so they've got different bloom implementations here. Disabled a sort of blur version. Right, so after here they should set. Okay, what's this one? Now render the floating point color buffer to a 2D quad and tone map HDR colors. Right, this is the shader I want to see. So there's a sort of a program choice, nothing. So they're binding a texture. Ping pong color buffers, whatever that means. I don't know what that means, to be honest. And then, so the color buffer goes in as one texture, and then they're rendering the quad, and I guess the render quad shader. Damn it, OpenGL. So, yeah, where's the shader? Right, so I'm interested, what are they doing? I guess MIP0 is the final. It's already it added on. Oh, it might be actually. MIP0 is it already added on. So maybe you should start, okay. MIP0 is probably the final render that you actually want to use, right? Okay, that does make sense. Both methods rely on the quad VO. In the downsampling, we fetch the MIP chain, activate the shader, run the loop. Upsampling is very similar. Okay, let's read this bit. Upsampling is very similar, except it does things in the opposite order. It starts from the low resolution MIPs and works its way upwards to the MIP chain. Let's start by fetching the MIP chain, activate the shader, and for the filter radius, you're free to experiment. Then we enable the additive blending to perform whatever the previous D was. Sorry, the new D is equal to whatever the previous D was plus the blur of the previous image. By the additive blending, D quote is equal to D. So you don't need to make a copy of D in this line. Oh yeah, so there's only additive blending, that's all they're saying. Whereas we actually had to load it explicitly. B4 is the filter radius given in textual coordinates, not in pixels. Now that we write from the MIP to the next MIP, which is our first iteration, which means MIP is the smallest section of the MIP chain, and the next MIP. That's just to do with the way they've done their for loop. Again, we render to a screen filled quad with the correct viewport size. After we're done, we disable the additive blending and disable the active shader. Yeah, so where's the bit where they do the tone map? Because they say they tone map. Now render to flimple buffer to 2D quad, tone map. That will actually do the rendering. Yeah, but then bind frame buffer. So I guess at the end of this, do they like where? Yeah, bind frame buffer 0. Use program 0. Are they not using a program? Like, I forget how OpenGL works. Like, how are you, like, doing things, like... So you set active texture 0 to be the color buffer. For crying out loud, OpenGL. So when you bind program 0, what does that do? OpenGL bind program 0. Like, how does that work? Does anyone know how that works? Like, how does that work? Surely there's a shader that gets ran. I mean, now, but they probably call somewhere at the start. Yeah, but what they do is they do this sort of render bloom texture, right? And it calls render up samples, which is here, and it use program 0, right? So then they bind frame buffer 0. So that's like, imagine the swap chain image. There is sort of viewport back to that. Then after here, there's no use program, right? There's a... Oh, what's this? Shader bloom final use, right? Getting stomped on by OOP. Hang on a minute. Okay. Right. I think this is it then. Bloom final. Yeah, so there I'm back. Okay, this is it. Alright, we found it. Okay, so it's in this sort of tone map. Depending on the bloom, they get the bloom. OOP, you will continue to confuse me until eternity. So, render the quad, right, obviously launch that. So, 3 is the new bloom, obviously it says new bloom, so, oh, 1 or none. So the new one reads in the HDR texture, the bloom texture, and does a lerp based on the bloom strength. Amazing. Right. Okay, so they were saying in the... I remember reading this now. They were saying in this article that the bloom strength, you want to keep it rather subtle. Okay, this makes sense. The image that we've got, this image that we have where it's like far brighter, makes a ton of sense now, because it means that you lerp towards this new image. It could still be wrong though. It's right here. So there's a lerp. Right. That makes a ton of sense. So yeah, 0.04 is what they suggest. Okay. That's cool. So let's go ahead and apply that to the... Right, we can do that quite easy. So that post-process one. Right, we'll pass in the bloom texture. So input... So this is the scene. Scene texture. We also want a bloom texture. Like that. So scene texture. Oh, it's on like a bloom strength, isn't it, basically? We'll put that in the settings. Smart. So we should probably put the light on in the settings as well, so we have a bit of play with that. So scene texture at that coordinate, and then you do the sort of bloom. So scene color, bloom color, and it'll be like color equal lerp. Oh, I forgot about lerp. Scene color. So it's saying that you want to have the based on this sort of like bloom strength. Nice. Just gonna make sure we actually get it from the bloom texture, and then we've got to actually in the post-process we put all the right things in here. So it's scene, and then bloom and bloom. Then we've got to make sure we pass in that bloom strength. So G settings, bloom strength. So we'll go ahead to the settings and code file. Again, we'll do a 0 to 1, but I think we'll have some form of multiplier where we can say like, oh crap, my laptop died. We should, misspelled strength. Yes, so we should have some kind of like cool. Multiplier for these in probably the shared area. Internal shared. So like a bloom thing. Define graphics bloom. Not bloom shared. Bloom strength. Max. Maybe we put a max about 0. I don't know. 0.4 or something. And then the other one is like, was it bloom filter radius, wasn't it? Filter radius max. I forgot what I did on that one. So that was in the... That was again when we launch it, isn't it? Yeah, filter radius. .1 for now, right? Okay, bloom. Okay, so, and then again in the post-process side of things, we can multiply this by graphics. Bloom strength max. And there we go. So we should probably also take the light that we've got and make a little light intensity thing so we can really sort of play with that. Where's that light? So we did like lights intensity equal G settings graphics light intensity. Oh. Okay. So we go ahead and add that to the settings file as well, so we can make it, you know, play around with it. And I guess we'll multiply it by, let's say 50. So this one we will remove in the future. It's just here as a way to have a bit of a play. So 0 to 1. So we'll default to 0.5 be 25. 0, you know, say we did 1 to 100, then that would make a lot more. Let's do it by 100, right? Okay, so, well, I think there's only 64 steps, so it might be quite crap if I did that. That'd be okay. Cool. So let's regen that. Okay. I'm just going to take a quick break and get another drink. But after this, we'll test out this bloom thing, have a bit of play with those sort of light intensities and just all the other little properties we just made. And then after we've done this, we'll go over maybe the plan for the materials thing on Sunday. And we might take a look at performance as well on the bloom too. So yeah, I'll be back in a minute. Right, welcome back everybody. How's it going? So let's test out the results. Let's see how good it looks. So I already see something. It's a bit bright though. It's hard to tell. We should have a way to disable the bloom actually. That's another setting we forgot. Let's go back into the settings and let's add a new. So with bloom, we probably want, I guess we'll have another one of on and off for bloom. But things about bloom, we might have different versions or whatever, I don't know. Maybe. So we'll have its own enum. Maybe. Bit dumb. We could probably have let's put the blooms together. We'll see how silly it gets. Bloom on. So with that, we need to go to where it is sort of like bloom, render bloom. Now, so this will do all of this. So obviously we don't want to do any of this if bloom is disabled. And if it's disabled, it's still going to generate a texture of some kind, right? So, sorry, we're still going to use the texture, that bloom texture. So we'll probably need the texture around. But if we had it at 0, no, we need a way to say if it's actually enabled or to say, yeah, okay. So what we're going to do is go, okay, if you don't have bloom, we go if G settings graphics bloom, if that is equal to v0 bloom off, there we go. Then we just return, don't do anything. And now I want to be careful here because when we do that sort of post-processing shader or whatever, where it combines the bloom in there, right? Well, the bloom texture is not going to exist. So I guess we can do something like this where we get the bloom and say, well, if it's equal to on, then use the texture. If not, pass in 0, right? And then that way we can just do an if statement inside the post-processing shader since it's just an index, right? So we can take that and go, oh, okay, well, if bloom, so by default we'll go, okay, well, color is equal to scene color then. Well, maybe scene color is just what color is. And then you go, okay, well, if cast it into an integer, if we have a bloom texture, then get the bloom color and perform a lerp based on the strength. And that will allow us to enable and disable without passing any extra stuff in, which would be pretty nice. So give that a go. Okay. Oh yeah, we did have that light source thing, didn't we? So, right, let's disable the bloom. Enable disable, it's not really doing much. If we open up the profiler, we can see, right, it's quite intensive because there's a bunch of, it's full screen, right? But we turn it off, turn it on. See there's this bloom pass here, it's taking about 2.3 milliseconds. It's quite long. We should probably try and optimize that in some way if we can. So yeah, we are seeing it actually get disabled. The balloon strength is not set to anything sensible, so this is why we're not seeing it apply anything. But yeah, as we turn it up, we are seeing things get a bit brighter. So we turn up the light intensity. I'm not really seeing any blue, I'm not gonna lie. Oh, the filter radius is 0. Okay. So we're starting to see something here though. Like, I think it's better if we just, let's go back to just one thing. Let's find where that one thing is for a minute. Where are you is the question. Well, alright, let's do 8 things then, because we can't do anything less than that. So now let's take a look at the bloom on these things. Have a bit of a look at this. So we do see something here, this sort of filter radius. The more we up it, we're seeing it sort of move around here. So I guess if you up the balloon strength, interesting. So we're starting to see it a lot, but it is kind of flickering around a bit. It's a bit weird. That's interesting. Let's look at the... Right. So you probably want to have this as a very small value. We already had it very small anyway. That's not the actual value. We did multiply by 0.1. We're getting some sort of like horizontal lines in the render, actually. So there's some clear problems there. If we turn it off and on again, if we open up the texture view, we'll see it. Let's go to the... Oh, did I click on the bloom texture? I went to the post-processing texture. So you'll see there's these horizontal lines that have been introduced. Is that right? That are very horizontal. If I just toggle the bloom. Yeah, let's toggle these sort of horizontal lines that appear. It's difficult. Bad eyesight simulation. Yeah, it's quite possible, eh? It's very true. Like when I see like a bright light, I see basically like stars. Like those are little stars. But yeah, these like horizontal kind of lines. I think we should really be debugging that sort of bloom texture. We take a look at the... Yeah, so this is kind of going all over the place. Bizarre. So I think so the down sample, if we take a look at the results of that, let's go to... We don't see any flickering here, right? So let's go to the up sample. The first up sample, we're going to MIP 7, then the second one. So we see that. Okay, it's interesting. And then we go to MIP 6. Wow. 7. Okay, then 6. There's so much more detail. So... Right, then does that. So where does the shimmering come in? Oh, I didn't mean to go 7. Let's go 5. So we put that in there, right? Okay, keep going. 4. And we apply it. Okay, that's alright. It just looks like it. Well, it can look better, right? I don't know why it's so blocky looking. Well, okay, because it's low resolution, but I meant it makes it look blocky looking when we get up into the high res though, so I'm a bit confused. That's when we apply it there, yeah? That looks better. Maybe because I had the bloom intensity up too high. Three. Wait, why is it so... Right, so we're not seeing it jumping around in these maps. Okay. Looking alright, isn't it? So that's before, then after. And then final one, boom. Ah, the final one does it. Okay. So that's where the horizontal lines are coming from. Okay, so that's good. We shouldn't have much of a bug to fix then. Maybe. So we'll go to the graphics, look out for render bloom, and we'll have a gander. So why would the final upsample well, maybe the sync code is being a bit weird. It could be that the filter radius is just too large. Like the filter radius just ended up being way too large as well. Maybe we could try that with the sync code a bit. Yeah. Let's see if that fixes it. See, I think it might be to that filter radius not being sensible value. So I think I have to bring it to about 8. Okay, let's get a bit of a zoomed in look. Okay, so open up the settings panel. Bloom is on. If I put a bit of filter radius on, bit of bloom strength as well. I guess we'll whack it all the way up so we can see the full texture. This is just the full bloom texture we're seeing. As soon as I whack that filter radius up just a little bit, it just doesn't... It's just so damn noisy. Yeah, so it seems like it's more than the... Yeah, it's a bit bizarre. Hey, Katsumoy, how's it going? Yeah, so the one that Cherno went over in his video is that one. Like, it's the same sort of one. He referenced these things as well. Same with Simon Dev as well. I think they both reference the same ones in their YouTube videos. It's the one from this Call of Duty Sledgehammer Games one. And then on Learn OpenGL, it's a bit hidden. The same one is also here in guest articles 2022, physically based bloom. So I'll drop it to it. It's the same implementation that's referenced in the Call of Duty one. So we just implemented this basically. Trying to get this one to work now. See, I wonder what's... So the final destination image, right? So the difference about that final one is it's no longer a texture view. It's a texture that has all of the MIPS in it, right? So could that mean... Could that do anything? Well, not really, because you never access that as the sample image anyway. Okay, so let's go to the shader. And figure out what the crap is going on. So, why are we getting... So we're doing our sample based on some radius. And we get these sort of like horizontal lines. Well, there is like a divide by 2 going on. So I guess it could get that. I don't know if that's doing... That will be fine. And you load from your current texel and you store to your current texel. So I guess where's that sort of like flickering coming from? Why is it changing every frame when the one that you're reading from it doesn't change every frame? So it makes me believe that we're sampling into the same texture that we're writing to. That's what it makes me believe. We can't check RenderDoc because my computer gets hosed. Nice. In that same article, I was reading the first comment. Might be to never know. Huh? I'm not sure what you mean. So you say don't ever look at the first comment. Okay. First thing I want to do is look at the first comment. Where's the comments? Usually there's comments here. Oh, they got loaded finally. I had to refresh it. If they should have changed they would have changed the article if it was a problem. Been out a while. Yeah, there's the Karras average thing. There's the bonus section as well. So NANs will propagate, right? Oh. NAN propagation. That's what we maybe had. So you didn't write that into the article. Oh. Oh, so he's done it with. So he's done it with group shared memory or LDS memory, right? Interesting. That is pretty cool. He's even got the dirt on it as well, the lens dirt. Nice. Great. That is good. Look at this. It's pretty cool. I wonder how he did it. Yeah, it's pretty sweet. I wonder where he's done the bloom. Resources, is it in there? No. If I can't find it in 2 seconds, I'm just gonna leave. Bloom. Down, yeah, down sample. Did he do it with the... So he added a threshold into his. So yeah, you can do without a threshold, but that's part of the bonus section is you can put a threshold in it if you want it. There's a lens dirt bit. Keras average thing we gotta look at. Apparently removes the flickers. Soft threshold if you must. They put their threshold in it. Alright. I'm interested in the LDS thing because I wanted to do that. Load LDS. Right, so what do? They do a tile count of group size 8 plus 2 times by filter radius of 3. It's actually... Oh yeah, it's a 3... sure, it's a radius of 3 and a... Okay. Yeah, so that's what I would have done anyway. Does he just preload the whole thing in? Preload the whole... Basically, it's 8... It's 8 plus 6, isn't it? Yeah. Squared. So... Does he just preload that whole tile, that 8 plus 6, whatever that is? That is 14, isn't it? 14 by 14 tile. Yeah, he preloads that whole thing into LDS memory. That's what I was doing. But you don't have to. You'll preload in stuff you don't want to load in basically. Right. Yeah, you want to avoid. There's like a bunch of extra samples you're doing which you shouldn't need to do. All right. Anyway, let's try and fix this damn bug. Yeah, I think it's the Karas guy from Epic Games because he's done a lot of graphic stuff, and obviously he got like super famous from the virtual geometry, right? You know, I think he's done a whole bunch of stuff. If you look, there's plenty of things with his name on it. Yeah, no, yeah, that's the one. See, I'm a little bit weirded out how the final time when we apply it, it's like something's going on with these samples. So from MIP 1 looks fine. MIP 0 also looks fine before we do this upsample on it. So we take the MIP 1, which has already been upsampled to, we've got the accumulated bloom, whatever. And then it gives us a weird result. So what I'm thinking about is, why don't we say, is that filter radius? It's just flickers, right? So why then? yeah, it sort of flickers around and stuff like that. Could it be the fact that this filter radius is... Well, no, we've played around with it, right? Yeah, let's play around with it again. Get more of it. Okay, so as soon as we put on like a little bit of filter, let's put bloom strength all the way up so we're just seeing the bloom image. You see, we're getting these sort of horizontal lines. Nothing, something. As soon as we put a little bit of something on. So that'd be times by 0.1, so 0.001. And as we up it, we get more and more, right? But it's sort of very flickery. Now, if we go into the texture viewer and take a look at that bloom texture, sort out this brightness thing. So this seems like we're reading and writing to different location. Yeah, I think that's the issue. We're in data races. I'm not seeing any flickering here, right? So, and if we go to the MIP1, we're not seeing any flickering here as well. We're seeing it looking a little bit weird, right? That's okay. That's just the values are a bit strange. Like the filter radius too high, so it's doing that thing. So, but when we do this final one, it seems like we've got a bunch of like, we're reading and writing to the same image or something like this. So that's what I think is going on. So how can we... Sorry, reading and writing from the same image is fine as long as we're reading and writing to the same textile, right? That's the idea. So I reckon, are we getting some kind of like... Is it the fact that this sample at a MIP level... Alright, so let's do this right. So let's print this out into the terminal. Let's print out upsample this to that. So we'll do like DST MIP, sorry, source MIP, DST MIP. And let's just see those. It should be as expected, right? It should go to 1 to 0. Yeah, so 7 to 6, 6 to 5, 5 to 4. Right. Now there should also be barriers in between all of these, which always put barriers down, so it's alright. What I'm gonna do is do a load instead of a sample. I wonder if it's deciding to load from... So rather than doing a sample, I'm going to perform a load on the source coordinate only. So if we get flickering with this, then I assume if we get flickering of this, maybe we can do adding a radius as well, actually. Hang on a minute. Let's do and then we'll multiply it by like probably about 100 or maybe 10. Let's not do that one there. Okay, cool. Oh no, you need a MIP. What MIP are you doing? 0. 0, that'll be. Oh crap. Okay, no, it'd be a specific format, wouldn't it? Crap. Oh wait, you could do a fetch. The text will fetch, can't you? On a sample texture. Alright, so I just busted the crap out of that shader. So let's see if we get the flickering from here. So let's just zoom in a bit on this corner. So it's up the... Oh. So what are we doing here? We're upping the... of the bloom strength as well. Okay, so the flickering seemed to have gone. Like we're just seeing obviously repeats of things. I think the flickering's gone. Let's just double check. Bloom. So I think then it's something to do with that sample. It's just something about the sample is just weird. So I don't see those horizontal lines in it anymore. So on that last one, when it's applied, we don't see anything changing between frames. So my suspicion is then, I guess it's probably correct, is it's something to do with like, we end up, for some reason, this ends up sampling from the it ends up sampling from the MIP 0 when it should be sampling from MIP 1. So maybe we saw that the source MIP was correct, but maybe when I created the bloom texture, where are they? The MIP views. So basically my bloom texture ID, say 56, will be the full texture with all the MIP levels. Then 57 would be pointing to MIP 1 only. 58 will be pointing to MIP 2 only, and so on. And that's what this one does here. So I'm thinking what's going on is that we're either pointing to the wrong one, which I don't think is happening, or something has gone on with, well, there's something else wrong, I guess. I don't know. Just have a look here. So we're going to do a core breakpoint. We'll just get in there in the debugger and just have a look. Alright. So MIP levels is obviously 1, and then the base, oh no, base MIP level is 1 as well. Okay, so we go through, we set up our texture view, and we even set the base MIP level to 1 as well. Great. So here's the texture view initialize. Let's see what it does in here. See, this is why it's nice to have like a different application like RenderDoc, because you can like just look at all the resources and stuff. It's really cool, but it just I've got it in a crashing state for some reason. I don't know what I've done. Anyway, we set up this sub-resource range. I think it's done all right. Just double check it. So view create info dot sub resource range base mip 1. Okay. That's all okay. Yeah, I don't think there's anything wrong with that per se. Okay, so that resource ID. Allocate. So the alias. Right, so maybe that's something to do with it. Like, well, no, because the Vulkan layer would have complained, but you're going it from the resource backend. Okay, so you've copied them from the alias one here. When you initialize it, right, that makes sense. Okay, so I guess this seems okay. Let's just come out of so let's continue and do that again. So the offset would have been plus some offset. Index 30 is this one. And that'd be 31 or whatever. So mip res, let's just take a look at it. Mip res ID dot raw and a few bits. Yeah, 31. So seems alright. Okay, so I think that's like that's going alright there. So it's nothing to do with the texture views. It might just be something to do with the. So we saw it, right? So 1, 2, 0. Right, so 0 is destination and 1 for source mip. So I'm just a little bit confused on how. So maybe they're always sampling from mip 0. Oh, they are, aren't they? No? Right, yeah, I think they're always sampling from mip 0. I don't know why that is, though, because in Vulkan, when we set the descriptors, so you say view initialize, you're getting your new sort of like texture view. So you put it to sort of like sample 1 area. And then you're filling in the descriptors. So those will get set for that specific texture view, right? So it points to a specific MIP. So when I get a sample image for that, I would expect it to be only on that MIP level, right? That's true, because in the texture viewer, when we take the copy, we use sample level. Oh, we use sample level. Yeah, we use it on the full texture anyway, the full. Right, so that doesn't make any sense. Yeah, I can't test that theory. But anyway, so I think if we go to the shader code again, and we instead pass in the sort of sample MIP here. So I think what we're doing is we're actually just always sampling from MIP 0. So we're not really getting the best results. And if we just did this instead here, we might have to then play about with that filter radius. So apparently that filter radius should change. It should get larger. It should get larger the further you go on. So maybe we just say multiplied by probably the by one shift left of index. So just be multiplied by 1 first, and then 2, then 4, then 8, right, and so on. So that might do it. And then we don't do this silly offset thing here. We just do the whole texture, okay? So I think that was a problem. We're just basically always sampling everything from MIP 0 for some reason. I don't understand why I was doing that. That's the current theory. Let's see if that's fixed it. So let's get in there and... Okay, so if we up the radius, filter radius, and put the strength all the way up. Right, so we are definitely seeing a different result here now. That radius is way too high. Or there's something about it, but we're not seeing any flickering anymore, so I think my theory is correct. So that's where it doesn't change at all. This is where it's clearly too much. Yeah, so I think that's sort of the scaling rate, at least, might just be too high. So maybe we just do multiplied by 1 plus index instead. And that might be better. Alright, let's try that again. So I'm glad we fixed that bug, at least. Now it's just a case of tuning the bloom a bit. So let's bring up, oh, this is good. So this is the bloom intensity, we're just whacking all the way up. So this is what the bloom texture actually looks like. Okay, so that looks better, although you can clearly tell that, like, this radius needs to be really small, and it probably changes based on the resolution of the screen, based on the way we've done it, I think. So that's also a bit of, if you look at these guys up here, they're sort of like a 3x3 pattern, yeah. Does that 3x3 pattern change? I don't think it does. Seems pretty... I think it does change a bit, to be honest, based on the resolution. No. It's quite alright. Okay, so that's good. So we just need to sort out that that range. It's just it steps too much. So again, is it this multiplication factor or is it this max? I think it's the sort of max radius we've got. So let's do 0.01 instead. That's the most you can do. So the way it is right now is the more MIP levels there are, as well, that's another weird thing. The more MIP levels there are, the more this is going to get multiplied, which is problematic. So really, we should probably do it the other way around. It's like from the so we should probably have some like there is a value which it is. So let's put it back to 0.1 actually. Probably still quite high. Okay. There's a value what it is like. And then based on the MIP level you are, you just divide it by that MIP level. So if your MIP... Yeah, so maybe we pass... Okay, maybe just do a divide by... So whatever the MIP level that we are reading from, that's always going to be 1 plus something else anyway. Okay, so that will then mean the higher it goes, to the lower the resolution is, the more it's divided by. And the less it steps, is that right? No, you don't want that. No, I think you just want it pretty even the whole way. Because we're sampling from the same No, they specifically said it should change. So you want it to be larger distances. Oh, let's read that thing again, I'm confused. Upsample. Here it is. Using B4 as a radius to spread out the lookup positions. An important detail is that we need a different radius for each upsample with a larger radii on the larger MIPS. Okay, so a divide might be better then. Right, let's give that a go. See how this looks. It still looks a bit pixely though, I think. Maybe that's just because maybe we fixed it. Let's see. Okay, so we plop that open here. So we'll turn that on there. Let's turn up all the bloom so we can see it. So this is when it's just a little bit smaller, still it's very pixely, but as we increase, there we go, it's looking much better, isn't it? That's looking nice and soft. So let's put this down into a little thing here so we can actually just blind our eyeballs with this white light. Avatar Game Man Engine, exactly. Engine without a game, that's what it should be renamed to. See, I think we should have some kind of like... We still see the pixels about here, this is not good, right? That looks good. But if I did something like, you're starting to see pixels here. Especially down here, right? So 0.1 is quite a good number already, right? Because yeah, we multiply this number at the bottom by 0.1. That's what I'm saying. So, like these are you still kind of see in the, or maybe the amount that we're dividing by is too wrong for the lower MIPS. So maybe it should, sorry, it's too much for the lower MIPS. The amount that we're dividing by, right? So should we perhaps floating point half this number before we, or quarter of that? Maybe. Just have a play and see what happens. So let's see how the bloom texture looks now. So let's plop that there. How's it going, Rust Compiler? How you been? It's been a while. So we'll put up the bloom strength, so we're just seeing the bloom texture. We expect it to be pixely here because we've not got any filter radius. As we up the filter radius, it becomes less pixely now, right? That's interesting. And as we up it even more, okay, it gets more and more apart. Okay, so there's kind of like a sweet spot, right, of the value that we need. Or the pixelation goes away, and then we get kind of more into it repeating and going a bit crazy. Okay, because he just gets too wide. Right, so I think then that times 0.5 is not really interesting. Maybe we should just say there's like a min. So if the min was 0.1 and then the max was 0.2, say, and then we give you like a sort of like, so you multiply by 0.1 basically, and then we add the min. So really I should just take this and just filter radius. So yeah, scale that. So this is a 0 to 1 value. Take the range, scale it down, then add the min, and that'll get you a value between the min and max, which is 0 to 0, 0.1 to 0.2. So if we play around with that, we should get more sort of like a better looking bloom texture, and then we can play around the bloom strength and see that as well. So let's get about here. Bloom. Let's just see the bloom texture, just bring up the strength the whole way. Right, so this is at 0, which is basically 0.1. Then we up it even more, and we start to see it sort of, these sort of get a bit starry and repeat, right? So as we bring that in, it gets less. Okay, good. So that's all right. I like that. Let's just keep it at 0. It's fine. I'm fine with that. So let's take a look at this bloom strength now. Let's bring this down. So the person was suggesting about 0.4 or whatever, and it's sort of like, now if we 0.04, wasn't it? So I think we just directly threw that into the, no, we didn't really directly throw it into that. Yeah, we multiplied it by 0.4. So to get 0.04, you need to be like 0.1. Yes, they were suggesting something like that. So we have something like that, and then hang on a minute. There you go, bloom off, bloom on, bloom off, bloom on. It's interesting, isn't it? So we could then also take into account like what happens if you there you go. This is the material editor which we're going to be changing anyway. But let's put an emissive. There we go. It's looking alright now. I haven't got an emissive strength, but it's just got a sort of it's adding it the color, but we're seeing it repeat here. So I guess we play around in the scene viewer. Sorry, texture viewer, and look at the scene texture. And oh, sorry, I meant the post. Oh, it's there. So here, can you see that glow? It's alright, doesn't it? So I guess I can also just hang on a minute. Bloom off, bloom on. I like that, it's good. So if we put it at 0.1 as the default in that file, the values are they were kind of alright, wouldn't they? 0.1 on the bloom strength. We play around with the light intensity as well. Let's hop out of that material viewer. So we'll talk about the material viewer in a minute because we're going to go back onto that. But yeah, I quite like how it looks. So yeah, that's right. So it is kind of this is where we are starting to see some of the texels here. Depending on how bright something is, it might actually not look that great. Let's look at that. Yeah, so this is what the texture ends up looking like. Oh, it's looking rather boxy, isn't it? Mm. Yeah, so maybe the way we're working out that. But maybe some of the ways we're looking at that within that filter radius is still not right. I think that's what it is. Let's go to that settings file and put a default strength. It wasn't it? 0.1 I wanted. Okay, let's regen that. So I would say that it's probably this filter radius. You know, it would. Let's just fetch the texel next door, right? Let's put the radius as 1 texel and just try that because I'm struggling to find a good way to do it. And maybe we could say it's kind of yeah, so for this MIP level, the one that was sampling, we've got the dims, right? So you don't really have a texel size because it's kind of like, you know, so let's get the largest dimension, max element float. So let's get that BC source dims, right? So the source texture is just get that max element, and then we do the 1 divided by that. That's 1 texel. So then if we can so now we take this sort of like filter radius and let's just say, right, now multiply this. So I get you like 0. Yeah. Right, so let's just say, yeah, multiply by that. And we're going to go ahead and go to, let's comment that out. Let's go to the settings file and let's change the range of it to something like, hey, it's minimum of 1 to about, I don't know, 10 pixels. Might be a bit too much. Oh, wait, it's 10 pixels for all the... Yeah, let's do 4 pixels. So somewhere in between there, we'll get a float slider for that. So let's see how that looks instead. Okay, so there's a bit of a play there. So it is already being applied, you can tell it's quite bloomy. But I wonder how much this has an effect. Oh wait, I wanted to see the... Let's put the bloom strength all the way up. I wonder why that goes past 1, but there we go. So we increase that radius. We're not really... You know, I do start to see some pixels, not gonna lie, around here. What? And then when I put it down to 1 as well, I do really start to see some pixels there, but... Okay, so now I'm interested in like, well, if I zoom out here like this, there was that sort of like... What was that problem again? There was the... There was, when we increased the light intensity, it was looking kind of blocky, wasn't it? So I guess let's bring this grid down a bit because it's a bit much. My face. So we put that intensity up, but it's not really looking blocky now, isn't it? I think it's better. Oh, that's looking blocky. We're seeing it now. So if the bloom filter radius isn't big enough, it really starts looking like blocky, right? Okay. Right, that's good, that's good. So if we have this... So I'm doing it in pixels. The person said don't do it. It's not in pixels, it's in UV space or whatever, but... Mine's in pixels at each MIP, so it is... Wait, is mine shrinking? So it's saying here, so by using the radius in texel space, the radius will automatically grow during the upsampling procedure. Grow. But the way that I read that is, hang on a minute. The way that I read, so it's doing this sort of thing right here, right? If you look at this image, sort of tent filter, E is wider, right? So if I've got 4 texels in E, which is the smallest resolution, that is wider, right? And then as I accumulate it up the MIP levels, that wider sample will affect, yeah, all of the higher resolution MIP levels, right? I think that's correct. So it's not the fact that the radius is getting bigger the larger the MIPS. It's more of like, so by using the radius in texel space, the radius will automatically grow during the upsampling procedure. So it's like it's passing the result of that to the next MIP. And therefore that's sort of like it accumulates up, if you will. So like a pixel from here would make its way. Oh, what's the way of saying it? Yeah, so I think this is correct. It's confusing. I think the way we've done it is correct. So we just gotta like so a MIP at the lowest resolution MIP, 4 pixels is a wide space. But then at the lowest resolution MIP, 4 pixels isn't that much of a wide space, right? And that's what you want. So we're still got that doing it this way, but I'm doing it in pixels and then translating it into UV space. All right, good. So, 1 is a bit blocky, 2 is not blocky. So I think what we'll do is we'll still keep that range from 0 to 1. I like that. But what we're going to do is change this min to be from about 2 to probably 4. That seemed like a good range. Would you ever go with moustache only? Nah, I'm not really a fan of the moustache look. To me, the moustache look looks weird. Like, people are trying to bring it back. It's definitely like a tech thing at the moment. People wear a moustache, but it's it's definitely like, what is it? Like whenever you see like an old TV show of someone like the 70s or something on like American TV, you see like the moustache, and yeah, people are trying to bring it back. I'm not sure. It still looks weird to me. I like a full beard, obviously. It's interesting that people grow their beard out. I've not bothered trying it yet, but I don't ever want to do the full beard thing. Maybe I could play around with the beard a bit more though. I just have it sort of, well, I'm a bit lazy with it, but typically that's sort of a quite an even cut. But yeah. How about you, Hermest? Hermest? Are you a moustache fan? Like, people also do some interesting stuff. Like, they sometimes have like, they'll have like, they would just have this sort of like area here with hair, not just completely shave all this, and maybe they'll sort of like shave out areas here. I think that's pretty interesting. Like, if you have your sort of own little interesting thing, that's alright. But just a moustache, questionable. Well, it kind of gets annoying when you're eating food, etc. Bit messy, right? When you're like, yeah. Well, that's why you sort of like trim it down around the mouth, right? You sort of like come in, and I got to do mine soon. But yeah, you'll like give it a good clean up. When it starts going in the mouth, and also I guess it depends on how you kind of eat your food as well. Do you sort of like put the spoon in your mouth, or do you just sort of just just sort of slap it on your face? So yeah, guess it depends on the eating technique too. I think that's the way. Oh, I'm happy about this bloom. This is gonna be great. So why are we doing bloom, right? I guess that's a good question. Because we're doing material stuff next, and I'd like to talk about that. That'll be on Sunday's stream. Let's look right at it. Oh, so we like. What can we do? We can jack up the bloom strength. Let's just have a look at it. We do kind of see some pixels, but that's okay. But we can smooth it out a bit and all that. That's good. That's good. All right, and then like It's alright, it's alright, it's alright. 0.1 on it. Good, good, good. Light intensity, let's jack that up and see it go. So, this doesn't look too good, to be honest. We're seeing kind of some lines here. That's because the filter radius needs to go up. Now, it is a 1. So 2 is probably not enough. You probably need a filter radius of at least 3. Oh, crap. Excuse me. I didn't use... There we go. Wrong settings. Okay, so let's put the light intensity up, see what we get. This is default. Move the camera around a bit. Okay, so I don't really see anything there. That's looking kind of nice. And let's change that filter. Ready to use. So I'm changing it here, it's increasing. So it starts to sort of look a little bit weird there. So we've got a good value, whatever we have it on here. We'll change the resolution. Right, we change the screen resolution, that looks a little bit weird sometimes. So we might need to scale it based on the screen resolution as well. Alright, so just things to play around with. I think we're good. I think we're good though for now. So let's talk about why we are doing this. So we've now just finished up on this. We finished the checklist, guys. This is great. So I think we started this in December. I had a month planned. Ended up as 2 months. Classic schedule. You know, so we've done all this, right? We've done occlusion buffer, transparency, and rendered HDR tone mapping. We've just done bloom as well. So the goals for this year is to make a material editor. So we've got to actually add like texture support and stuff like that. PBR, we already have PBR. We want to have like a model editor so we can make these sort of like ellipsoid, you know, characters and scene environment stuff. And then a basic way to place that in a level. And then we probably want to have a way to build characters and things like you can maybe move around as well. So that's probably a bit of a stretch goal. So the material editor is next. Oh, we've done this render a bunch of ellipsoids. We've just done this one right now and remove the horrible glitches. We've probably got, you know, there's obviously bugs, right? But I've pushed some occlusion buffer bugs there, and this bloom's a bit too harsh now. Let's turn this down. It's like a PS3 game. Well, no, PS3 games are probably worse, but let's turn that intensity down a bit. Okay, so basically, I already made the material editor. We did start on this before. As you can tell, you can edit a material, and you can change like albedo color. You can change the emissive color, and it's got this sort of history thing. It saves it out to a file. We built this sort of like, we built this way to sort of save data and load data in, which is pretty cool. So we've already got that all sussed out. And yeah, this is the reason why we added bloom, right? Because we want us to see it actually pop off the screen like that. Much better. So I don't really want to do this way of doing it anymore, where you create materials with just sort of fixed things. Ideally, we want textures, right? Because we want to look at a sphere, and we want to have a sphere, and we want to have like more than one material property per sphere, right? This applies to the whole sphere. Ideally, you want a texture where you can sample these and get different albedo colors and emissive and metalness and roughness properties over the whole ellipsoid, right? So we're going to be using materials all going to come from textures. So I was speaking to Ross Musco about this. He was a viewer on the channel. I haven't seen him in the stream for a while, but he's in the Discord. And he uses procedural texturing. And he does it per, like, literally in the shader when you're trying to shade the thing, which is really flexible and interesting. But when you sort of zoom out, I think you're going to have problems with, like, you want, like a MIP level and stuff like this. And also I want it to be fast. So, because, you know, the shading cost will go up the more procedural texture stuff we have, complicated procedural texture stuff we have. And so the way I'm thinking about doing it is we just literally expose a shader, which just generates a full resolution albedo texture, emissive texture, metalness and roughness texture, and probably a height map. So we can generate some normals. So this way you can do some funky sort of like shading and make it look like kind of not an ellipsoid, but the ellipsoid's got sort of like engravings in it or whatever, right? So it will look like it's got extra detail in it, which we don't really render with geometry. And so, you know, that's what people do with triangles, obviously. So we're just doing that with ellipsoids. And then we can simply just, when we do the material shading pass, or when we ray trace and hit and do the material shading, we sample those textures and do the PBR pass based on the UV that we hit. And so what is the material editor going to be? So we're going to have these sort of material shaders, which allow you to procedurally generate textures in the editor. But you don't procedurally generate them when you run the game. They're procedurally generated when you sort of edit properties. So I think we're going to, in the encoder file, so we'll have like an encoder file, like, which is, you know, a way of defining types and stuff like we have for the settings here. We'll have, whenever you make a new material shader, you make a new structure, right? And put all the properties in there you want to configure. And then we've got, like, it does generate type information. So we'll use the type information from that sort of material file to go over all the structures. And all of those structures map to a material shader. And all the properties are for that material shader. And those will be exposed in the editor automatically. And you'll be able to tune the properties. So you'll be able to have custom properties for colors, like a foreground. Like, whatever the procedural texture wants to have exposed. So different colors, properties, or different strengths, and just whatever, right? Or how many times you want this pattern to be repeated, and what's the spacing between the pattern. The shader can do anything it wants, and that's the power of it. So these material shaders are not going to be like, so if I have someone who comes on to do art for this project, the person will probably need to have a little bit of programming knowledge if they want to change these shaders and do stuff like that. But ideally, the idea would be that these material shaders would be available to just sort of like tinker with and get different results and be flexible enough like that. So I think you can do, like, as an example, if you just look for like shader toy wood. So we'll be able to generate like a procedural wood texture and just have different sort of like properties exposed. And then, like, we could change, we'll obviously have to generate a albedo, emissive, normal, metalness, roughness map from this one shader. And yeah, we'll have sliders so you can change maybe the noise pattern a bit, or like the scales of things, you know, stuff like that. and you know, we can get some really funky looking stuff. We just take a look at stuff like this, really just get inspired. So yeah, we could just basically make a bunch of configurable. That's interesting. A bit toy looking. But yeah, that's cool. And then expose those in the editor, and that will be the material editor, I think. So we'll then have a way of, so all of the materials will be expressed in the code base as code and data properties. And then there'll be a generator which will go over all of those and compute all of the textures that we need. And I won't have to check those into the repo. So it's just a case of when the repo gets downloaded, and you just have to run this material generator. And ideally there should be a build system which just keeps track of like what is built already and builds it. So that'll be cool, meaning you don't have to download a lot of textures and stuff when you sort of download the game and try to get it up and running. So that'll be interesting. And then, yeah, so that's what we're going to be working on next. So I maybe should think about it, but maybe a couple of weeks, 6 streams maybe. You know, basically probably February, half of February, or all of February. Something like that. And then after the material editor, we can move on to doing something else, perhaps the model editor, or maybe just some general stuff which keeps up, keeps the project running smoothly, I guess. There could be something to do with like, hey, we need a build system now, or hey, we need, some things might pop up. So we'll see. Cool, let's just find someone to raid in the meantime. So yeah, for now, there's a Discord channel. Come and hang out in the meantime. Thank you for everyone who's supporting the channel. Appreciate you guys. Appreciate the support. You can support via Ko-Fi. There's a link that way, I think. Am I pointing the right way? Boom. And also via Twitch as well, but Ko-Fi is the much better way to do it. And you get access to the code if you support for the month via the Twitch or Ko-Fi. Right. So let's see if there's anyone on. There's the Jai guy. Alright guys, have a good start to your weekend. I'll see you all on Sunday. We'll get started on this material editor. So I'll get this code up on the GitLab for those who have access to the code. And again, thank you for everyone who's supporting. And yeah, have a good weekend guys. See you in the next one.